Hi everybody, sorry that I'm away today. Hopefully this video will help us keep on track. I want to talk to you today about key features of parabolas. It's sort of a consolidation of what we started in class on Thursday. Okay, so we'll start us off with the graph of the day. So I'll give you about 30 seconds to just look at the graph and interpret it and tell me what you think. So, okay, 30 seconds, think on your own, no talking. Okay, so now I'd like you to turn to the person next to you and spend about 30 seconds to a minute just talking about what you see about this graph. So now turn to the person next to you and have a chat. What do you see? What is today's graph of the day all about? Okay, go. All right, so hopefully you've talked about a few of the key features that you see in this graph. Number one, I hope that you've noticed that there are two graphs shown on here. So one of them is a linear graph and the other one is a parabola. It is a quadratic graph called a parabola. So the little legend on the side tells us that the pink, the straight line is representing the costs, and then the other dot that's the other line with the sort of maroon color represents the revenue. So if you know about costs and revenue, revenue tells us how much money is coming in. So what is the total value of money that we're earning that's like coming into us at the end of every day? And then costs are the things that we have to pay for. So it might be the cost of materials, might be the cost of your employees, the hourly wages that you give them, that kind of stuff. Okay, so you'll notice that the cost function, or the cost graph, is linear. And it has a positive correlation. So hopefully some of these things are things that you talked about. The positive correlation means that you can see down here this says quan, that stands for quantity. Oops, let's go back. So as the quantity increases, so as we make more and more and more of some product, the cost the cost is increasing. So with greater quantity comes greater cost. That makes sense. If you want to build 25,000 of something, it's going to cost more than it would be to build 5,000 of something. That makes sense. So this pink line makes a lot of sense. So now let's talk about the revenue. So the revenue shows this parabola, which is kind of weird because you'd think that the more things you make, the more money you would bring in, but that is not actually true, and there are a few reasons for that. So number one, if you have zero quantity, so you have no items, you can't make any money, so your revenue is zero. Whereas with cost, you might not have built anything, but you already have costs right away because maybe it cost you a bunch of money just to rent the space where you were going to sell those things. Or maybe it cost you a bunch of money just to pay your employees to show up on that first day, or you had to train them first before you were able to sell anything. So it makes sense that your costs would already be high before you can sell anything. But revenue, of course, if you don't have any items, then you can't make any money. And then we can see here as you start to sell items or for all the items that you make, you start to bring money in. Okay, so we have some growth. So we have this increasing, this positive correlation right here. And then that continues to go up, and then at some point we get to a peak, which hopefully you remember is called the vertex. And then after that, the revenue starts to go down. So there are a few reasons for that. Number one has to do with supply and demand. So if you make a lot of something, then that doesn't mean you'll be able to sell everything that you make. So if you talk about let's say something simple like a bicycle. Let's say these are bicycles that you're making, and you make 25,000 bicycles, but maybe 25,000 people don't need bicycles. So maybe you're living in a town that has 500 people, and once you've sold those 500 bikes, you can't sell them anymore. So your supply has exceeded your demand, which means that you have a bunch of things that you've made, but you can't sell them, and so they're not going to bring you any revenue. So you're going to have lost money on building them and not gained it back in selling them. So that can go down. Lots of other reasons why a parabola represents revenue, but I kind of want to move on. So I do want to talk about these two places right here, which hopefully you recognize are points of intersection. So notice we have 2 points of intersection with this parabola and this line. Now, these points of intersection represent the places where revenue and cost are equal. That means that all the money that you're spending is equal to all the money that's coming in. So if your revenue equals cost, then what does that mean about your profit? Revenue equals cost. What does that mean about your profit? I want you to think about that. Okay, hopefully you've concluded that revenue, which is the money coming in, when that equals your costs, which is the money going out, then that means that your profit is nothing. So you've made exactly enough to cover all of your costs, but you haven't made anything beyond that. So that's what we would call a break-even point. So you have one of those at about 5,000 if you build 5,000 bikes or whatever it is you have. And then you have another one of those at about 15,000. So that would be another break-even point, and then after that you lose money. So notice after the first one you start to gain profit, and after the second one you are back to negative profit. So those points of intersection are really, really, really important, and that's where we kind of, everything sort of comes together with the spiraling, because we've talked about points of intersection, we've talked about lines, we've talked about parabolas, and in a problem like this we have all of those things happening together. Okay, so we'll deal with that problem another time in more depth, but just to sort of give us an idea of where we're headed with this. Okay, so I want to just spend a minute talking about what we did on, oh sorry, it wasn't Friday, this should say Thursday. So what we did on Thursday. So that was when we had those experiment stations. You were doing different experiments. I want you to pull those sheets out, and I'm going to ask the supply teacher to actually stop the video after I finished introducing these questions, because I want you to reflect on what you learned from that day. So these are the questions I want you to think about. So how are lines and parabolas different? Okay, so on Thursday you had some experiments that were lines and some that were about parabolas. I want you to compare them. What makes them different? The next question is, in what kinds of scenarios are parabolas present? So where did you see parabolas? Where did you see quadratics? And where did you see lines? So I want you to compare those. The next one I want you to consider is, what scenario had the truest representation with a parabola? So which one seemed to fit the parabola best? Was it the one with the basketball? Was it the one with the blocks? Whatever, which one makes the most sense? And then what would all the scenarios equations have in common? So that was one of the activities where I had you look on Desmos and compare the equations. So what was in common with all of those equations? Okay, so I'm going to ask the supply teacher to stop and give you a minute to think about this, and then talk to each other and share, and then we're going to continue. Okay, so stop the video right now and come back in about a minute. Okay, so hopefully you've had a chance to chat. Now I'm going to bring us here, because this was, if you remember this experiment, this block building, this was the experiment that really had the truest representation with a parabola. So I'm going to break this down for us. I'm going to sort of take up what we did here. So this is an example of the most basic parabola. We'll talk about this in just a sec. And so hopefully you filled out this chart, where starting, first of all, if you had a length of base of 0, then you would have 0 unhidden cubes. So we're going to go ahead and add that value into our table. Well, if it'll let me. Oh, it's not going to let me. Okay, I'll do it another way. Oh, computer trouble.